We will be covering frozen sets, just I don't know whether I covered it along with sets, but anyway, I will touch upon that. Then the main focus of today is going to be on dictionary. So what I thought, uh, we have two slots today, 6 to 7 and 8 to 10. We will use this for something about dictionary, talk about theory, and then more samples programs we will write. I will explain it using this session. Tomorrow, Tuesday, we will have a lab. Okay, so that there will be a continuity on what we discuss now and down the line from 8 to 10. Okay, I hope it is okay with you guys. If you have any other suggestion, you can always tell me. So let us look at some implementation details of dictionary. I will give you some idea which will make you understand how things work underneath, and we will see the examples after having seen some of this high level theory portion of it. Okay, now before I go into dictionary, let us see what are frozen sets. Frozen set is a new class that has the characteristics of a set. It is like a set. A set is a set of numbers or objects which are individually immutable, but the set itself is a mutable object, and we know that it uses this as a key. All the elements in a set are keys, and it uses a hash function to address them or locate them in the structure. Whether an element, when you are looking for a particular element in a set, it will use a hash to locate whether it is there or not. Now, the same principle is used in the dictionary. In fact, dictionary came first and then the set came later by removing the values. Now, one thing that we have seen is a set is a mutable object. It's a mutable object. So we cannot use this as a key. The set itself cannot be used as a key in a dictionary or in another set. You cannot have a set inside a set, because if you try to keep a set inside a set, this set itself is immutable, mutable, so it cannot be part of a set. Now, what if you want to have such data structures where you like to keep a set inside a set, because it's quite possible that you like to have such things in your data structures, then the solution would be to use the frozen set. What you do, you create a set which is a frozen set. That means you are guaranteeing that that set will not be modified by adding any element or removing any element. So the elements in a set remains constant, and individually they are immutable. That is okay, but even the set itself is immutable. Now that's what we are giving an assurance. Once we say that a set is frozen, then it becomes eligible to be a key, because you can apply a hash function and compute a key or an index into a hash table. So let me tell you, hash function is the algorithm or a function which is applied on an input that you are giving. It could be an element in a set. Then we find the index or whatever is the index into the table, which is the output of the hash function for an input, and then we look for this input object, whatever we gave, whether it is present in the table or not. So if you want to do that, a set inside a set or a dictionary as a key, then we need to have a frozen set. So while tuples are immutable list, we have seen that the difference between a tuple and a list is this is immutable, whereas this is mutable, which can be changed. This is immutable. A set, a tuple is immutable. So this is like a again you can do a iteration or list of things. Same thing what you can do with the list, you can do with the tuple also, but the difference is mutability. Similarly, frozen set and the set is a difference is only the mutability. So sets being mutable or the reason is unhashable, so they can't be used as a dictionary keys or as another element of a set. On the other hand, frozen sets are immutable and hence hashable. Thus, they can be used as a key to a dictionary. So, how do you create a frozen set? This is not capital; it should be small. Let me correct it here. Okay. So, you have created a frozen set A and B, and you are using that as a key here to be added into a dictionary. So, still we have not seen a dictionary. We will see that now. Okay. Any questions here so far? Okay. Now let us look at a dictionary. It's a dictionary has a key value pair. This I have already told you earlier. Now let us see. These are the keys. These are the elements which are immutable. Now we are giving a string here and we compute the index into the table and locate the values. Now let us look at how it is implemented. Little bit more detail. Of course, all the data structures that we use in Python, they are all implemented in C. Okay. Underneath many libraries, all which are very important to have a speed in terms of execution, they're all implemented in C. So the dictionary is also implemented in C, and it's a structure kind of having a value hash key. These are the elements. A C structure having hash key and value for every element that you have in a dictionary. So a dictionary is nothing but maybe a table, an array of structure. Now, how many elements that you can have, we don't know. We as we keep adding to the dictionary, this grows. So, what does the Python do? Initially, they created. Talking about C Python, I don't know whether it is changed now. Okay, C Python. Okay, I have to write it like this. C Python. This implementation, what I am explaining you is what I have seen in some time back, but I don't know whether it is still followed. But still, the logic will be same even if they have optimized it or improved the performance or implementation. The philosophy that they follow to implement the dictionary is the same. So let us try to understand one way of implementing, which is of course there in Python in maybe some earlier versions of Python, or even it may continue in the recent versions of Python also. So to start with a dictionary, we don't know how many elements we will create it. When you say that I want to have my own dictionary, and you open it up, when you open it, we don't know how many elements you will add it is purely based on what you want to do with that. So what does the C Python do? It doesn't want to occupy more space, so it creates an array of 8 elements to start with, and then they may add it. If the number of entries are more, then the table will grow. It has to be adaptable. Now, why are they going with the structure of a C as well as an array? Because they want this to be a contiguous space. You know that C arrays are contiguous. So initially it is in a contiguous space. And can they fix the size? Yes, of course they can fix the size. Sorry. Because you know that hash, maybe it will depend on the hash function they use. The width of this will be based on the hash function they use. But the key and the value, they are all going to be references to some objects. So the size of this element can be of same size based on the object reference size. Okay, whatever is the object reference pointer, whatever is the size of that, it could be the width that you need to store these values in the structure. So it doesn't matter whether they point to some other object which is of different sizes and occupies more memory, but the actual structure of this array is not going to be growing because it is going to be a reference to these objects, and the reference pointer itself is not going to be changing in size. The width of this, how many bytes they reserve for storing the hash, depends on the algorithm. So effectively what I'm saying is one element of this array is going to be of fixed size. So they can create an array of structures. Now they have to now find a way of indexing into this. So what is done is the hash function is used, and it will compute the value, whatever is the hash value, and then they try to find out based on the algorithm the one of the index. Okay, if it is only 8, they will, the hash value whatever they get, they will mod it with that, and then it will come to one of them. So once a hash value of an object creates an index, so how do you do that? You say I is an index that you want to do it into the array, is nothing but the hash value and ampersand with a mask. Okay, this mask is ampersand, you do an and because you need to make sure that whatever index you get is within this particular value, whatever the length of the value array. So once that is computed, then it will be able to access the element, a particular index location will be chosen, then an element is added, a new, whatever hash value is computed is added, as well as the entries, whatever keys you give, whatever value you give, you keep adding. Now what if you keep adding more and then there is a collision? So suppose you are computing a key or a value of I, you are computing for a new key that you are given. Now that new key also can happen that it is pointing to the location which is already occupying an entry is already occupied. This is already an element is there. Now let me explain this little bit more clearly. You have an index, an element which is having a hash, and the key is corresponding key and corresponding value, and an index is computed for a, this is maybe I call it as a key 1. You do a key 2, on hash you find this hash function returns a value I which happens to be the same as this. Now what is done is this is resulting in this index, and the hash values are same but keys may be different. Now you will this, it will compare the keys of both. Though different keys are resulting in the same index, it may result in the hash value, same hash value maybe, but keys are different. Now it has to find another entry, new entry it has to create and add it to the dictionary. This is what is called collision. It could happen, okay, when you have more number of entries in the dictionary and you keep adding it and deleting it. Now the algorithm what is being followed is to go into the um, array. Suppose you are starting with 8 to start with, then it will look for any empty or a entry which is free. There may be any elements will be there or may not be there, so it will look into the dictionary either in the order, the next free, it will go through one by one, or it could also do a pseudo random order. Now what is being done is a pseudo random order, which the algorithm which is followed also is repeatable, that it will create, it will generate another index which could be occupied or it could be free. Then it will look for that particular index, and if it is free, then it will add that element. Now the key 2 will be added into another location which is free. Now what if you are adding this, and then when you are trying to find out whether an element is there or not, when you are looking for an element, then it is again going to create a key 2. It is going to pass it on to the dictionary to look for that particular entry in the dictionary. Now again the same sequence of operations will be done. It will do the hash function computation, it will again come into the same location, and it may go down and then find out that the next entry which is available, and it will find out the element is there, and it will give you the value. So this is how a hash entry is created and added to the dictionary. Now what if the dictionary is full and you are keep adding it? Then it needs to be increased, the size of this will be increased, and maybe a realloc will be done, and then the whole thing will be copied. It will be little time consuming, but the dictionary will grow as you keep adding more element, or maybe keep deleting it or removing the element. So now this is how this is happening, the addition of new element and increasing the size of the dictionary. Now this increasing the size of the dictionary does not happen when it is full. It will happen when two-thirds of the dictionary is full. Then it's like a low watermark or high watermark. Normally, even in memory management, this is followed in operating systems. They don't allow anything to be full completely before taking action. They will, even garbage collection happens the same way. So two-thirds of the dictionary is full, then it will start expanding the dictionary table size and then start growing it. So this is the little background of how dictionary is implemented. If you maybe come across somebody asking you in a question in any interview or something, maybe you can explain this to give a understanding of how it is done inside. So now is a normal dictionary is like this, separated by a colon, and elements are added by with a comma. Now this is what I was explaining you. Key A corresponds to this entry, and then B, and then a C could result in a collision. Then it will do a probing. This uh, activity of looking for another free entry in a dictionary table is called probing, and it will find out another free location and then add a key and value there. Okay, so these are all contiguous spaces. This is the array of structure I mentioned, and it stores a hash value also, which is not shown here, and something may be free. You may find some free locations also based on the number of entries in the dictionary. I hope this is clear. Now, what are the built-in methods that we have? I will use it with the program, but let us try to understand what are is there. Removes all the elements. Clear removes everything. We saw that in the other cases also. Copy does a shallow copy. Then from keys, this is which I'll explain to you with an example. Okay, little different. This is to get a value. So this is how you will probe the dictionary, whether a particular key is available or not. So when you do a get and pass a key, the same set of operations that I mentioned while adding the element to the dictionary happens. So once you want to find out whether a key is there or not, we are not looking for a key. Of course, we are looking for a value which is pointing at the key is pointing at the value. So when you want to do a get, then it does the same operation. It uses the key value, it computes the hash function, and then mask it with the size of the table. Then it will get a particular index. Then in the index, whatever is there element, it will compare it with this key. If that is not the key, then it means that even during addition, there was a collision, and it went for locating another free location for adding this element. So it will go on doing it. And if suppose if it probes everything and then it finds that there is this key is not available, that means this element has been removed, or it was never added into the dictionary, and it gives you error that the element not found in the dictionary. So this is how searching through the dictionary happens. And one more thing, I mentioned that the dictionary is unordered, right? um, Let me change a little bit now. Maybe I will come to that. The current dictionaries, whatever we have, 3.8 and above, they are ordered dictionaries. Okay, they try to maintain the order in which you are uh, adding into the dictionary. When you are again trying to get an items, or when you are trying to get the elements in the dictionary, they put it in the same order in which those items were added to the dictionary. So they are somehow internally maintaining the order in which those items were added to the list, to the dictionary, and then giving you back. So this new feature has been added from 3.8. Since we are using the same version, we will see that. Okay, and there are some functions to only get the keys in the dictionary. or only get the values. This is it will give you only the values in the dictionary, and it gives you all the list of all the keys there which are there. Now, pop is another two operations to remove only a particular element from that. Clear removes completely, it erases the whole dictionary and makes it uh, completely zero. Whereas pop gives you some item, the last item what has been added. Since I said that it is maintaining the order, you can get the last item that has been added to the dictionary. So, and then set default, I will tell you this is with an example, it will become clear. Okay. Now, ordered dictionary. So, prior to version 3.8 or 3.7 or earlier versions, the dictionary did not maintain the order in which the items were added. So, there was a requirement for an ordered dictionary which was taking care of that. When you are adding adding multiple elements, the order in which you added them is also internally maintained in this ordered dictionary. Then when you are trying to list them, or when you are trying to extract some item based on the order, maybe last in first out, or first in the first item you want to take it out, or the last item you want to take it out, those kind of operations were possible with the ordered dictionary. Okay, so though currently the dictionaries are ordered, some operations supported by ordered dictionary are not supported here, even though it is maintaining a ordered dictionary. So we need to learn about ordered dictionary also to understand the difference between them. So we will cover that in the session when we meet at 8 o'clock. Okay. So let me summarize. Dictionary was not ordered earlier, and then from 3.8 they made sure that the dictionary also ordered. So since previously dictionaries were not ordered, they had a separate object which is called ordered dictionary, which took care of maintaining the order in which the items are added to the dictionary, so that you can remove element specifically from the dictionary, as well as when you're going over the dictionary, it will give you the list in the same order in which they were added. Okay, so later on this dictionary was added with the feature that it also maintains the order in which the items are added, but some features which are there in this supported here are not supported in the the dictionary which is having the ordering support from 3.8. So we will cover that later. Now, dictionary is an associative data type. It's called associative because it associates the data element, sorry, keys with the value. Keys can only be any immutable object, which I have mentioned many times, and values can be of any types. Okay, mutable or immutable. So we can have a college with a name, and this in this case everything is immutable, but you can have a list also as a value. Now, how do you add it? You can use an array notation to add an element into the dictionary. So this is the dictionary, and this is a new key that you are giving, a new key you are adding, which is not there. This is one key and this is another key. These are the values. Now, for this new key, you are giving a new value. So you can do it like an array index. You can add a key like this and then assign a value. Now, one more thing. Suppose if you do college, you and you say name equal to something else, maybe triple AT. I wanted to make it triple ATL. This is also allowed. You are changing the value of the one of the key which is already existing. So what happens is when you do this with a dictionary, this is supposed to be a dictionary. When you are saying that I am adding a key, or giving a key which is maybe there or may not be there. It could be a new key or it can be a existing key. So as soon as you try to index into the dictionary with a key, the routine job of looking for this key in the dictionary happens. Okay. Now suppose hash function has given you an index, and then it finds that the name key is already there. This is a key which is already there. Now you are assigning a new value to the entry. Now this is overwritten with a new value. This object is put there. Now what happens to the old object? It could be garbage collected later on. So you don't worry about this pointer anymore, which is pointing at this triple IT string, which will be replaced. Now what if while probing or searching through the dictionary you don't find this key at all? That means it will it will search whatever is possible and then say that okay, it's not there. That means it's a new entry, so it will add a new entry. Whatever free index available, it will add the new entry, and that's all, job is done. So it could be that what you are passing could be present or it could be absent, so you can change it. I think from 3.7, not from 3.8. From 3.7, insertion order preservation in the dictionary has been guaranteed. Okay, so let me stand corrected. It is from 3.7 onwards we are doing it, not from 3.8. I mistook it. Okay, the redesign improved the performance and memory usage also by 20 to 25%. They did some redesign of implementation of the dictionary. So whatever I explained you may not be there currently. It could be changed, but roughly this is the way they internally implement the dictionary. Now order dictionary module in collections, it is part of the collections module, was used earlier to make ordered dictionary, which I mentioned it. Prior to 3.7, only ordered dictionary guarantees ordered dictionary. Okay, I hope this is obvious. The dictionaries were not maintaining them in the order. Okay, you can maybe see some documentation related to this here. Now another function, reversed. Okay, reverse is the key in the dictionary. So suppose you have a dictionary. Okay, I will explain what is the function, but maybe we'll see a program also so that you will understand it. Suppose you have a key like this and then character A, okay, comma, key B, colon, character this B. So these are the values. Sorry, this is a dictionary. Now reversed, if you do a reversed on this dictionary, it returns a new dictionary, okay, which is actually it doesn't return a new dictionary. You need to do something more. It reverses the keys. Okay, it gives you an iterator object which is reversing the keys order. Suppose it is in this AB order, it gives you in BA. See, remember it is added in 3.8. That means what? The dictionary is already ordered. Remember that. So prior to 3.7, it was not ordered. Now any dictionary is ordered. So when you can reverse it. So because the dictionary is already implemented in ordered fashion, you can say that, okay, this is the order in my dictionary is currently there. I want to reverse the complete order. Now the dictionary ordering is based on the key value. Okay, always anything to do adding or deleting, everything is with respect to the key. So even the reversing is with respect to the keys. It doesn't bother about the values. So it takes these keys. It would have been in this order. Now it may change this also, change it in the reverse order. Okay, so we will see an example of how the reversed works on a ordered dictionary since the Python version 3.8. Okay, so the ordered dictionary which was there prior to this making the dictionaries ordered, there were some functions pop item with a keyword last. Okay, you can mention whether I am looking for a last item which has been ordered to the list, ordered to the dictionary, or I want the first from the dictionary. Suppose you have a dictionary which is ordered dictionary. I can have any number of items there which are of course maintained in the order. Then when I am doing a pop item, I have a freedom to say whether I am interested in getting the first item which has been added or the last item which has been added. That is called a last variable, which is passed to the parameter. It's a parameter which is passed to the function of pop item, which you can say I want it true or false. If you say true, then it is the last in first out. This is followed. If you say false, then you are first in first out. You are taking out the item which is added the previously, the first. So you can either do it in any way, either LIFO or FIFO order of removing an item, which is only supported in the ordered dictionary. This option is not there. It is always LIFO in the if you are operating this pop item on a dictionary, but ordered dictionary gives you this flexibility of either removing the first item that you added or the last item that you have in the dictionary, that you will be giving it using a variable parameter which you can be initialized with the true or false. Okay, that we will see with an example. Move to end is also only supported in the ordered dictionary. That also I will show you. If you are interested in moving an element in a dictionary to an end of the dictionary. So suppose you have an ordered dictionary which is created. Okay, it is in the ordered way, and then you want to move one particular element which is with a particular key value to the end of the dictionary. Okay, that move to end function will take care of taking out one particular key which is, I suppose that it is present in the dictionary, it will move it to the end of the dictionary. Okay, that is also supported in the ordered dictionary APIs. Okay, that we will see. Okay, any questions so far? Maybe talking too much. Okay, other than my own message, nothing else is there. Any questions from anyone? I don't know whether explaining about the implementation helps you, but I thought having an idea of how it is done internally will make you feel good when you are using the dictionary. Okay, so that's the intent of teaching you. For a programming course, you don't need to go into the detail, only the syntax is needed, but that will be a little boring. I don't think you need a teacher for syntax. You can always do it yourself also. Okay, now let us look at the nested dictionary. We have a dictionary wherein you can add another dictionary into it. Now, immediate question you may have is, I have a dictionary, okay, and suppose key is there, and then a value, then key, maybe key 1, key 2, value 1, value 2. But when you are adding a dictionary to a dictionary, what happens is the dictionary itself is a mutable object, right? Then can a dictionary be, can it be a key? Can it be a key in another dictionary? It is not eligible to be a key in a dictionary because it is mutable object. Dictionary can be mutable. So any mutable object cannot be a key. Now, how can you then have a nested dictionary, okay, a dictionary inside a dictionary without having to worry about this? So what is done is you have a dictionary and then this whole object is used to refer to the internally, okay, mechanism. It doesn't expect this to be a frozen dictionary or something, but it gives you a flexibility that you can have a dictionary having another dictionary entry into the dictionary, next to the dictionary. I will give you an example implementation wherein what is done is it is creating an anonymous dictionary and then you can add it while adding a dictionary into a existing dictionary. Okay, that it is implemented in such a way that you will be able to address them as long as the first key is there, the next one will be taken care of. Okay, so they compute the hash function accordingly, that the next dictionary also can be arranged. So it will be like a element addressing the another element. I will tell you how it is accessed. It's like a multi-dimensional array. It can be accessed. Okay, maybe with an example you will be able to understand it. Right now, don't worry about it. Python nested dictionaries are a collection of one or more dictionaries built using a nested keys. Okay, so it uses a nested keys to internally implement it. Okay, somehow even if the dictionary that you are adding is not a immutable object, it has a mechanism to keep it inside. It's a collection of dictionaries. Slicing next nested dictionary is not possible. Slicing, what you remember, that start and the end indexes, and then step. So you cannot slice in the dictionary. So though it is ordered, you cannot do a slicing. Okay, similar to indexing, like a list, you can do a slicing wherein you are looking for a particular element, and then you do a slicing of, in terms of step you can go through. Those things are not possible though it is ordered. Remember, I mentioned that list is ordered, so it is possible to index it. Okay, it is possible to index into the list because it is ordered. Now, can I index using normal numbers in the increasing order? Okay, I am talking about indexing means 0 to n. Okay, that kind of indexing or slicing is not possible in a dictionary, though it is ordered from 3.7 onwards, but it is ordered based on the keys. It is not like what you do in the uh, maintaining a list of items in a list, wherein you are doing it with an index which is a number changing from 0 to n. But here the key is the uh, entry which is helping you to identify whether an element is there or not. So it is ordered based on the keys in which, as well as the order in which you have entered the item. So it is not possible to slice it using the slicing operations that you normally see in the list. So nested dictionaries can be shrunk or grown as needed. You can always add, in fact, you can even change this element, okay, dictionary with another element or value, because dictionary itself is mutable. So you can do it even though it's part of a dictionary, okay. Is accessed using a key, as I mentioned it. Any number of nesting is allowed as long as there are no empty dictionary inside, okay. There is one condition that dictionary cannot be empty inside, because you can add a non-empty dictionary and you can put it any number of nested dictionaries and it allows. So you can either have anonymous dictionaries to create nested dictionary, or you can create anonymous means you don't give a name. It is like this here. This dictionary, you have created it. Now you have a dictionary inside, okay, this dictionary. Now this is anonymous because it doesn't have a name for it, it doesn't have a label for it, okay. You have created it and then added into the dictionary, so it goes into the dictionary and no longer you can access it directly using any label, but you can access it using this key. Of course it is part of this dictionary, but you cannot add identify it using a label. So that is called anonymous dictionary, which we normally do it in lots of functions also. When you are passing parameters, you create a object and you pass it to the function. So some places it is anonymous. You create an anonymous object that is popular in C++ also. So similarly, you can create a nested dictionary using anonymous dictionaries. Okay, or you can also create a label, right? Identifier, label or identifier, both are same. So I can also, instead of this, I can assign it to a maybe red square dictionary, okay, and then I assign this dictionary and mention this label while creating a nested dictionary. I can also create a nested dictionary using a label, so that is also allowed. Okay. Homework, I'll mention it. Maybe you can do it later on. Create a dictionary of ASCII values, both small and caps. And how do you create it? You can create it with the odd. See, this odd in a odd function gives you the ASCII value of whatever alphabet you give, and then you can convert it into a character. Okay, then str, that ASCII value, whatever you get, you can convert into a string character that ASCII value represent. Okay, so what I want to do is I want you to create a dictionary, ASCII dictionary of ASCII values of the alphabets, both small and caps, as well as a number 0 to 9. So the keys are ASCII values. Keys are ASCII values. Okay, how do you get ASCII value? You use it like this: ordinance of a, that give you. So ASCII value itself is what? In integer. So integer is eligible to be a key because it is a immutable object. So I want you to create a ASCII dictionary. If you pass a ASCII value, it returns a string which is the representation of the particular value. Suppose 41 or 31, whatever values you pass, you will get the ASCII value as a string from the dictionary. Okay, so you can do it using these conversions. Print ASCII dictionary. Okay, it will be like A will have a value of 97, B is 98. Okay, this is what you will get when you print it. Okay, what I want to do is I want the ASCII values to be there on this side but not there. So this is a string. I told you the reverse way. What I want is if you pass a single character, it will return the ASCII value of that. It is stored. Okay, you are storing a ASCII value of a character in the dictionary. So this can be anything, but it also happens to be an integer. Doesn't matter. So this table you have to construct it. It's not very difficult. Okay, just an example. Maybe you can create a nested dictionary with a small and caps numbers as a first category, and then keys are A to Z or capital A to Z and 0 to 9, and values for each of those keys are A is A1, A capital A is A followed by 1 and 0 followed by 1. After having created the above two levels of dictionary, add another sublevel for each of those above categories by adding another dictionary which maps the keys. So it will be like this. Okay, so sublevels can be represented as a small one, caps one, and nums one. Okay, I want you to create another dictionary with a small one, caps one. These are all the keys, and they have to be representing these values. Okay, sample print is, suppose print your homework dictionary. It should print a small which you have another key which is small one and value is A. Okay, and then caps one is A, something like this. Okay, when you try to print these values, you will get A12, A13 like this output. Okay, um, think about it. How do you get this output? And these are the keys. Maybe when we see some examples in the next section, you will be able to really understand the homework also. Now this may be a little bit confusing because we are not even seen an implementation of a dictionary. Anyway, I can explain it to you later also. No issues when we after the whole thing is done. Okay, this maybe we can do it in the lab tomorrow or we'll see. Okay, don't worry about it. uh, we will talk about it later on. Okay, after we look at the implementation. Okay, I hope the theory portion is done. Okay, how dictionary is implemented and what are the different APIs or functions available in the library, and then what are the different order dictionary, and then why it was later on made as a ordered from 3.7. We saw these things, and when we meet at 8 o'clock, I hope 8 only, right? Yeah, we will run through some of the programs. I'll go through each of those features, and then we'll come back to this PDF again, and then homework also we'll come back to that again. Okay,